Ah, hello, flat Earth researchers, debaters, and debunkers. I was just trying to connect the software and do the title and all that jazz before I kicked off. That's because it was already public when I went on. I'll tell you what, let me get things set up properly and we'll go from there. I was going to try and arrange some way to for people to call in if they wanted to. Maybe I'll do set up a Google Meet. Hi, I can see a few of you in there already. So what do you reckon? Carry on with this stream or end it and start again? If it's looking good, I may as well go with what we got. Yeah? Yeah. Don't go anywhere, let's just carry on. Yeah? We'll adjust all the other stuff as we go. What's that? Hang on, I've just got to minimize this a minute. Meet or Hangouts is best. Okay, that's what I'll do. What I should also do, so give me a sec. I'll put my email in the description. All right. Boom. I don't know if that is going to show up. What I'll do is put my email there, nick@stretchoutmedia.com, and in the meantime I'll get a quick hangout set up or a Google Meet. Give us a second. I was hoping to open two different things, but that's not happening. That's okay. Basically, if I set this up, a Google Meet, I won't share the screen or anything. It'll just be the audio that you'll hear. Okay. All right, that's set up. That's ready to go. So how you all doing? All right, let's have a quick look at the see who's in the chat. Glenn, hi. Plain Truth, hello. Uncommon Sense. Drew Scott, hi. I've seen a few of you about already today. You must have either a lifestyle that allows you to spend a lot of time online or a job that allows you to flick between things. So FPV Angel, some good content on your channels today. It was nice to catch up with some of your information about the nature of rainbows. Glenn Souch, why is gravity missing? We'll go through that. It's a really funny article. I think the writer is has kind of done some tongue-in-cheek writing there. So yeah, we'll have a look at that. So what I was going to do is basically kill time for a little bit with going through these articles and discussing what's being said here. And I wanted to go through. You can see I've got a document below me that I've written down some notes, basically talking about the whole thing that we're dealing with here and the reliance on indirect evidence, because obviously that's all anyone has. So as we go through this article, just keep in mind the kind of indirect evidence that we've all been given and we've all heard repeatedly, that has just become kind of consensus, to say that we know we live on a globe, right? And the one thing that's lacking is any actual measure of curvature or any actual observation of it. It's all indirect evidence. So let me just get to that then. And I'll come back to the... Oh, okay, you got to go to bed, Uncommon Sense. All right, man. Catch up later. Get your sleep. It's more important because you know you can always come back to this. So, yeah. All right, let's rock and roll. I've got this article open. Here it is in Scientific American. Just scroll up. So the article is Reliance on Direct Evidence Fuels Dark Matter Doubts. All right. So pinning down the universe's missing mass remains one of cosmology's biggest challenges. Okay, I'll just read through it. I might stop at a few points because there are some funny, ironic things to point out. But let's go for it. Most of the matter in the universe remains missing in action. At least that's long been the standard cosmological paradigm. Now, however, a small but vocal group of cosmologists is challenging the dark matter tenets of the widely accepted cosmological model, which holds that the universe is composed of roughly 70% dark energy, 25% dark matter, and only 5% normal or baryonic matter. Dark matter, whatever it is, exerts a gravitational pull, but only interacts with ordinary matter very weakly, if at all. Beyond that, light seems to have no effect on dark matter, hence its name. Right. It's already seeming to be quite elusive from this introduction. Evidence of dark matter's influence on the cosmos stretches back to the 1930s and has only gotten stronger in recent years. NASA's groundbreaking cosmology satellite, the Wilkinson Microwave Anisotropy Probe, has, in the decade since its launch, delivered a robust indirect detection of dark matter's footprint on the ancient echo of light known as the cosmic microwave background. And dark matter's effects are also inferred in gravitational interactions around clusters of galaxies as well as around individual galaxies themselves. But the dark stuff itself has yet to be detected, either directly in particle physics laboratories as a new subatomic particle via neutrino telescopes, also operating in the subatomic realm, or with concrete evidence of such hidden matter using telescopes operating in the electromagnetic spectrum. Some astrophysicists are hopeful that the Fermi Gamma Ray Space Telescope will deliver corroborating, if still somewhat indirect, evidence for the mutual annihilation of dark matter particles in the galaxy. This is it's like an atom in a haystack, let alone a needle. Dark matter comes about because people unquestionably find mass discrepancies in galaxies and clusters of galaxies, says Mordechai Milgrom, an astrophysicist at the Weizmann Institute of Science in Rehovot, Rehovot, Israel. Stars at the very edge of spiral galaxies, for instance, rotate much faster than can be explained by Newtonian gravity alone. The picture makes sense only if astrophysicists either modify gravity itself or invoke additional gravitational acceleration due to an unknown source of mass, such as dark matter. The mass of visible matter falls very short of what is needed to account for the gravity shown by these systems, Milgrom says. The mainstream assumes it is due to the presence of dark matter, while others, like me, think that the theory of gravity has to be modified. Ooh, he's going to step on a few toes there. This is something that we know is difficult and challenging for anyone to do. Even the most learned professionals in the field have difficulty introducing any ideas that go against the consensus, or the Newtonian and so forth gravitational concepts and theories. All right. Just checking that everything's going swimmingly there. Where are we? Milgram's doubts about dark matter have long kept him on the fringe of professional astronomical circles. But as Rutgers University astronomer Jerry Selwood notes, people are beginning to think that we should have found some independent evidence for dark matter, and that hasn't happened. What does that remind you of when you ask people for measurements and evidence of curvature, bendy water, things like that? Yeah, a lot of people are starting to think that we should actually have some evidence, proper evidence pointing towards that. That is arguably largely a result of the fact that dark matter is theorized to interact minimally with normal matter. But some observational campaigns have not seen the effects of dark matter where it is expected to exist, just like we don't see curvature where it's expected to exist, or any of the other things that are supposed to be happening on a spinning globe Earth. So, theory predicts that spiral galaxies, including our own Milky Way, are enveloped by massive dark matter halos that provide the galaxy's missing mass. So we've got imaginary halos of imaginary mass that's supposed to be there because of some theories, but can't be detected, can't be seen by any means whatsoever. But it's there. But the Milky Way's own dark matter halo has yet to be detected, even indirectly. So that there isn't even any indirect evidence of a halo, but there is this presupposition by these learned individuals or groups of people that halos exist. Its putative existence is primarily inferred from the anomalous rotations of satellite galaxies, such as the Magellanic Clouds, which orbit the Milky Way, too quickly to be explained by ordinary gravity alone. Right, so the further we look out into space, the more mystery we actually find, and the more questions we get, and the more we realize that we don't actually have any answers at all. More recently, it goes on, there have also been predictions of a disk of dark matter that would reside in the galactic plane, co-rotating with the Milky Way itself. But in an analysis of the movements of some 300 stars located at least 6,000 light years beyond the galactic plane, Christian Moni Bidin, an astronomer at the University of Concepcion in Chile, and his colleagues conclude that there is no compelling evidence for such a dark disk. Given uncertainties in their own analysis, however, they acknowledge that such a dark disk's existence cannot be completely ruled out. So give us some more money to continue looking for this thing that we have absolutely no evidence for whatsoever. All right. Let's go back to Moni Bidden here. The lead author on the paper detailing the finding in the November 20 issue of the Astrophysical Journal Letters says that one can always conclude that dark matter escapes detection because it has an exotic nature or unexpected properties. But failing to detect it in indirect kinematical measurements, such as ours, he says, means finding a way out is harder. Yes. Another dynamical complication comes from the so-called Tully-Fisher relationship, which describes the relation between a galaxy's luminosity and its rotation velocity. The higher the luminosity, the faster a galaxy rotates. The measured rotation speeds on the outskirts of a spiral galaxy, Milgram says, depend in a very distinct manner only on the total visible mass of the galaxy. But if the theory of dark matter is correct, then the speed of stars rotating on the galaxy's outskirts should also depend on the shape of the galaxy's dark matter halo, which hasn't been found and has no reason to really exist. Dark matter halos should be lumpy, under-inflated football shapes, but not spherical, says Stacey McGaw, an astronomer at the University of Maryland College Park. Statistically, that means we should see many different galactic rotation velocities for the same luminosity. We don't. Well, fair shout to the writer here. They've gone and got their sources. So they've done their homework at least, but can't really seem to find any conclusions after interviewing three astronomers. Instead, McGaw says, the baryonic tail wags the dark matter dog. In other words, astronomers can predict just what the galactic rotation curves will be from a given galaxy's stellar distribution. McGaw makes the claim that if dark matter is dominant, observers shouldn't be able to predict the galaxy rotation curves by what they see in normal luminous matter. I must admit, I'm getting a bit lost here now. Obviously, these guys all know what they're talking about. In their unique astronomical language, and I don't mind admitting that while a lot of us might not be familiar with some of these terms or even the topics that they're talking about, it still doesn't detract from what's actually being said here. That essentially this idea that there is dark matter, because they had to come up with something that goes with or against gravity or replaces gravity or enhances this idea of gravity, because that doesn't work, then they're having all these problems actually trying to find it. Where are we? Okay. Even if dark matter raises questions on such large galactic scales, particle physicists are hopeful that it will be detected in the lab. If dark matter particles in the sun, for instance, undergo self-annihilation, then such annihilation events could create high-energy neutrinos that would potentially be detectable with ground-based neutrino telescopes. That will cost a fortune. Then there are detectors such as the Xenon 100 experiment in Italy's national laboratory in Gran Sasso, built to register direct hits from particle dark matter. Xenon 100 is designed to search for the most favoured dark matter particle candidate, the weakly interacting massive particle, or WIMP, by watching for signs that a WIMP has recoiled off an atom in a tank of liquid xenon. That's like rolling a dice and hoping to win at the craps tables in Las Vegas. A recent analysis of an 11-day observing run in 2009, however, failed to identify any such dark particles, casting doubt on two competing groups' prior claims of possible dark matter signals. They really are scrabbling around in the dark here. Okay, I'm just going to get through this, otherwise I'll get distracted with the chat and I'll come through it. One problem in making such detections is the uncertainty over dark matter's density in the local universe, says Chris Myhos, okay, another source, an astrophysicist at Case Western Reserve University. Does the dark matter particle not exist, he wonders, or are we just unlucky in terms of local dark matter density, not being able to find any? Current direct detection scenarios include potential dark matter particles with masses between 1 and 1,000 times the mass of a proton, and with interaction cross-sections roughly 1/trillionth the size of a neutron. And by finding these things, you're going to get all the answers to life, the universe, and everything. Because a particle bounced off an atom in a gas canister. It really does get ridiculous, doesn't it? After each non-detection, McGaw says theorists continually redefine the interaction cross-section of WIMPs to safely undetectable levels. This kind of behaviour, he adds, can spark a new, never-ending game of leapfrog between experimental physicists and theoreticians, allowing them to continue business as usual without ever revising their cosmology. that's quite a poignant point. Think about it again, okay? This kind of behavior, basically, looking for something, not being able to find it, and saying, okay, we've got to adjust some things here by a fraction and do this again, run the experiment repeatedly because we're not finding things. We've got to carry on doing it until we find something, and we've got to eliminate a 1,000,000,000 to 1 chances, blah, 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 blah. This is all just perpetuating the funding, because these guys have got this project going, and they want to keep it going, understandably. So let's read that bit again and just take note of what this writer is telling us. Yeah, this kind of behavior, he adds, can spark a never-ending game of leapfrog between experimental physicists and theoreticians, allowing them to continue business as usual without ever revising their cosmology. Okay, so on one hand, the fact that they are not finding anything related at all whatsoever, not even any indirect evidence to the theory that came about in the first place because of theoretical physicists playing about on whiteboards and things, yeah? They're just perpetuating it, yeah? They're rather than giving up and rethinking or just accepting defeat, as it were, they're just going to carry on, head down, and try and forge ahead with this thing. Then it goes on to say, we're near the end now, there is a lot of misplaced certainty in the dark matter model, a feeling that it's not if we directly detect dark matter, but when, Myhorst says. So, yeah, misplaced certainty. They haven't found anything yet, not even a trace of it, or even the evidence of it. But they're still hunting for it. Or, as McGaw puts it, once you convince yourself that the universe is full of an invisible substance that only interacts with ordinary matter through gravity, then it is virtually impossible to disabuse yourself of that notion. There is always a way to wiggle out of any observation. I'm going to repeat it, yeah? Once you convince yourself that the universe is full of an invisible substance that only interacts with ordinary matter through gravity, then it is virtually impossible to disabuse yourself of that notion. There is always a way to wiggle out of any observation. Yeah? Doesn't that just reverberate across the entire spectrum of so-called scientific discovery? Yeah? Where we've just been told this is the way things are because of theories and very scant evidence, mostly indirect evidence that always has more than one or more explanations. Yeah. So let's just zip up to the top there. Let's have a quick look at the chat there, see what's going on. Okay, Plain Truth sent an email. Okay. All right, let me open up my... Just a sec, guys. See if we've got any reactions from that. Let me just go through the chat while my email's opening up. V. Thomas, hello. Bear with me. Hope you're having a... What should be... Alright, okay. Hi, Travis. Okay. Alright, Travis, I'm gonna... From the Plain Truth. Let me just... Oh. Okay, there was some inaction, so I gotta start an instant meeting. Okay, sorry, just gotta start another meeting here. All right, the plain truth. An email has been sent to you. Let's see how it goes. All right, back to the chat. All right. This would be good. It'd be nice to have a chat with some of you. And I would welcome anyone who is wants to have a bit of a poke and see what they can come up with. And that, this is a thing. Having us just discussed the nature of indirect evidence, then this is it. You've got to think hard about what can you actually do. This is for anyone, all of us in this situation. What do we have in the way of direct evidence for any of our claims or beliefs? Yeah. Yeah, man, it's okay. It's a bit hectic to keep up with the chat. Hello, Tony. Okay, well, I can only assume that everything is kind of working well, and you can hear me, all that stuff. Chat amongst yourselves while we get this sorted out. Okay. Okay. Let's just see. If anyone, oops, whoops. Okay, no. All right, I'll try and keep up with it. Yeah. Very briefly, what I also wanted to look at was, not very briefly actually, this can take as long as we like. In fact, what I should do is swap these over. I don't know if you can see that. I hope you can. Let me just check that that's coming through on the thing there. I have no idea if just moving things around in OBS will just produce those results. All right. Okay. Not got any notifications yet that you're trying to join in. Travis. Let's see. FE Nation, hello. Lev Kung Fu, hello. V Thomas. If indirect evidence isn't good enough for dark matter, why is it good enough for some for the globe? Nice point. Yes. Okay. Exactly. Yeah. And that's what we realize, isn't it? You eventually, it does take a lot of, it does take a lot of breaking this down. You've really got to reverse engineer things. And you get to that point where you realize that there's reality, and then there's this concept of reality or where we are, the God view of us. So, and that's the thing, you've got a model with all these different explanations, but that's all it is. It's just a model. It's just a concept. It's like a concept car that never actually got built. It's just there. Oh, it does this, it does that. It works with hydrogen, and it can go at a gazillion miles an hour, and the tires never get flat, and it streamlines. But did they actually make it? No, it's just a concept. Yeah. Okay. Audio's good. Thank you, Lev Kung Fu. That's good to know. All right. What's happening? Are we getting anyone joining? Okay. Yeah. Oh, Tony, stop it. Alrighty. Now, okay. I'm not sure if it's the view is switched around yet. I'm trying to. Okay. All right. Maybe I need to do I need to transition? I don't know. I'm just reading from my little file here. Indirect evidence for globe assumptions. So the first one really is the whole Eratosthenes thing, right? You'll find pages and pages of it, and the whole entire model is based on that. Actually, it's something I wanted to go into on another video, really. But you've got this. You basically got a radius, right? There's a radius being worked out from a North Pole to the equator, or there's a circle, the circumference is worked out. So you have this very basic formula to come up with a circle. So, okay, the equator is what it is. We've got this circle worked out, and it's from having those dimensions. You have a radius, and then you have nautical miles. And you have which basically gives you a certain number of nautical miles for that radius, which and the circumference, and it fits nicely. It's easily divided by 360, and so then you get 1 nautical mile equaling 1 second, and then 60 nautical miles equaling 1 degree, and there you go. You've got basically distance converted into degrees, and so of course then you can make a circle from it. But you can have a distance that goes across a level plane. But if you, based on latitudes and what have you, you divide those distances up. You basically divide it up into 2020. What is it? 24,000? I can't remember exactly. 21,600. Nautical miles, so it's these 20 odd thousand pieces that it's divided up into. Yeah, well, that wasn't the topic. That's something I'm kind of focusing on for another one. Let's see. Are we having a joiner yet? I suppose it's already rocking and rolling. Yeah, it is. Okay. Let's see. Are you coming in, my man? Are you coming in, Travis? Essentially, I resent the email just in case. Yeah. All right. Hello, the Bristolian. Good to see you, Leon. Nice. Just so you know, in case in case anyone else wants to join. You can email me there, nick@stretchoutmedia.com, and I'll send you a link for a hangout. Yeah, and anyone's welcome. I don't mind. I welcome flat earth researchers, debaters, and debunkers. All right, looks like we've got someone coming in. Hang on there, my man. Hang in there. Hello.
Hello, hello, hello. What ho?
How are you?
Hey, how's it going? How's it going, fellow researcher, debater, and debunker?
Good, thank you. Very good, thank you. I can't remember where you're based. Where are you calling from?
I'm on the east coast of the states in Maryland.
That's right. Yeah. Okay. Wow. All right.
How do I sound? I'm on my car's Bluetooth. Am I okay?
Not bad, not bad. Let me just check with the chat if anyone can tell me whether you're getting the audio through here from Travis, all the way on the other side of the.
You almost said the globe.
Yeah. Yeah. So, what's up? This is the first time we've been able to chat, right?
Yeah, it's the first time you and I have talked, so I was excited to see you go live, and I'm just wrapping up my morning doing Uber.
Okay.
So I'm on my way. I'm on my way back to my apartment, and just thought I'd bug you for the link and just say hi. So yeah.
Oh, fantastic! No, great to hear from you, man. How is it being an Uber?
I'm enjoying it. I transitioned out of full-time truck driving, which was just not great for my sleep pattern, my health patterns. I wasn't sleeping well, wasn't eating great, had no time when I was finished coming off the road. I was always tired at the end of the week and
Right.
didn't have any motivation. And so yeah, I've basically tried to simplify a lot of what I did before, and I'm working, basically from 5 to noon and making the money I need to, and then I got the rest of the day to do whatever. So it's going good.
Nice place to be, isn't it? Yeah. Are you meeting a lot of people, and are you kind of what's the kind of what kind of mood are you picking up on? I mean, do you get to talk to people? Do they get comfortable having a chat? How does it go usually?
Yeah, I'd probably say it's probably about 60-40 for those who are quiet and those who are talkative. I pretty much try to engage in conversation early on just to get a feel, and
Right.
it's pretty clear when people aren't interested in talking.
Okay.
But I have had some really, really great conversations across the board, just about everything.
Uh-huh.
A couple of good flat earth conversations, a couple of good education, history, medicine, law, so great people that are people who are open to having those conversations. They've been really good. So yeah, it's enjoyable.
Oh, nice. So would you say that, I mean, in general, people are more awake, waking up, getting more dumbed down, or is it kind of hit and miss?
I would say it's probably hit and miss. I had one guy who was a Muslim,
Uh-huh.
and he was asking me, because I wear, if you guys would know the channel Good Times for All, or Zachary Zavala, if you prefer.
Yeah.
Yeah. So Zach used to do a show on his channel called Crocheter's Corner,
Uh-huh.
or Crochet's Corner, or something like that. So Zach crochets these skull caps that are made out of hemp.
Right.
They fit on the top of your head, they cover your ears or whatever, but it's made out of hemp. So I wear one of them while I drive, and I've had numerous people ask me if it's the Muslim cap.
Okay.
Called, but so this guy comes in and he's Muslim, and he goes, "Hey, is that one of those caps?" And I said, "No, I'm not Muslim." And so then we started talking about religion.
Mm-hmm.
So when I told him my story, he was like really intrigued. He was like on the edge of his seat listening, and he said, "Man, that's really great to listen to somebody who's an open-minded, critical thinker." I said, "You think I'm an open-minded, critical thinker?" And he goes, "Yeah." I said, "Wait till you hear this." So anyway, my point was that he had never heard of flat Earth at that point.
Okay.
So that was his first exposure, and he goes, "Well, I'm an engineer." I'm like, "Great.
Uh-huh.
What do you got?" So we had a good conversation. He was really cheerful, really good guy. Great conversation. Wasn't hostile at all.
Oh, fantastic! I mean, I've had similar experiences, and the Muslims, they basically encourage open-mindedness and challenging everything. It's like you're allowed to challenge all these things and basically find out for yourself. Find your own truth, and yeah.
Yeah, you know what, Nick? I really, really, really do believe that that seems to be the milieu of the spiritual philosophy, that truth is, this is the way I say it, truth is organic and truth is developmental.
Mm-hmm.
You know, I'm on a different journey than you are, you're on a different journey than I am, and we're both on a different journey than somebody who's like 16, 19, 25 years old, right? So
Yeah.
if we're all about discovering that truth, how can we ever be impatient with someone who's either behind us
Mm-hmm.
or frustrated by someone who's in front of us? You know what I mean? And we should be very open, very patient, very understanding.
That's brilliant. Yeah. Absolutely. And that, you know, and then we would all just get along.
Absolutely, yes, absolutely.
Yeah. It's so true. And that's the thing. If you come across people that have started exploring their own beliefs, then they're usually open to all of that, aren't they?
Yeah. So think about this though, because there is an aspect with Hermetic philosophy and esotericism where they will tell you that truth is not, or truth is subjective.
Okay.
But it doesn't mean that truth is meaningless, right?
Right.
So when you get into the metaphysical philosophy, you're going to have that ambiguity.
Mm-hmm.
And that's different though than science.
Right.
Science is absolute to a certain degree. I get it. I get the whole quantum mechanics, all that, and even what you were talking about earlier. You know, if you got hornswoggled into believing the model where, you know, this concept can affect this concept, well, you know, then you're going to believe everything. So I mean, I get that ambiguity that exists in the scientific field, but I'm talking about the fact that, like, let's say, Nick, you and I were talking, right? I know the sun is going to come up tomorrow. Nothing's going to stop it. Nothing's going to happen. It's going to come up tomorrow. I know that the moon is going to continue waning until it's new moon in 14 days or however many days that there is left, right?
Mm-hmm.
That's scientific proof. That's fact. There's no question.
Uh-huh.
So science is different than philosophy in that sense. You know what I mean? We do have to have a factual precision with science to a certain degree.
Right.
And then I think we have to be, and so that's what I was going to say. That's like we have to cross T's and dot I's in that field.
Uh-huh.
But when you get into the metaphysical philosophy, the dotting of the I's and the crossing of the T's can have different placements.
Uh-huh.
You know what I mean?
Yeah.
You don't have to cross the T in the same place. You don't have to have the same angle. You don't have the same diameter of dot on the I. You know what I'm saying?
Yeah, it like you say, it's more subjective than an objective truth. Can I just ask if you think that you know, there is a limit to being able to cross all those T's and dot those I's in so-called science or the physics and, you know, of just exploring our reality, but then that, so given that there is a limit or a boundary, is, you know, obviously we're discovering more things all the time, but is there a limit to that where we just have to turn back and go the philosophical route instead?
Yeah, I mean, that's a really interesting question, and I think that the answer, my best answer is, you know, it is both and. It is both precise and both ambiguous.
Uh-huh.
And I haven't personally been able to delve into the quantum field. I mean, I've listened to people talk about it, so I get the discussion. But in terms of researching it myself, looking at it myself, like, there are certain things that dark energy, dark matter, I get that that's a concept that, let's say, Bill Nye might want to talk about. You know, but if as a empiricist and as a synthetic scientist, if you can't demonstrate it, if you can't show it to me, then all I'm going to do is tell you, I'll take that into consideration. I'll hear what you're saying, but if I can't do it, if I can't see it, if I can't replicate it, then all I'm going to do is think about it.
Yeah. And that's fair enough. Yeah.
If that makes any sense, if that answers your question.
Yeah. Cool. Absolutely. Yeah. That's it. There is always a crossover, and of course, you know, the advances that we have made in science. I used the royal we there. I haven't done a bloody thing.
Oh, yeah, you have, man. Yeah, you have. Don't sell yourself short.
Yeah, but this is it. It's like this. I think, you know, we are, all of us, every single one of us, we have that desire for answers, don't we? There's a thirst for knowledge and answers, and
absolutely,
and that's great. And of course, it's only people, certain individuals that have been so driven in their lives that they've discovered something, they've brought something, you know, from the background to the foreground, and eventually changed the minds of the scientific community, which I suppose is kind of really what we're kind of talking about here, is just that forcing that change, even getting people to contemplate, as you said, take it on board, think about it. No, don't, you know, there's no demand for you to believe something, but yeah, take it on board and see how it fits into the big picture.
Yeah, absolutely.
This is fantastic. It's really fantastic to hear your how you. By the way, people are asking who this is. This is Travis, the Plain Truth. So I think if you've got a thing in the chat, people can click on that and go and check your channel out. But I'm sure a lot of people have already subbed to you anyway.
Yeah, I can plug my channel into the chat if that'll work.
Yeah. What are you kind of personally looking into, focusing on these days?
Well, I'm always keeping in my back pocket the research that I've been doing on my channel, which has to do with refraction and mirage with relationship to the horizon.
Yeah.
So my channel primarily is focused on that, but recently I have been looking more and more into spirituality and esotericism and hermetic philosophy, with understanding our spiritual physiology and its relationship to the cosmos, relationship to the zodiac, and all of the, you know, it's so funny when I listen to these spiritual philosophers talk about our electromagnetic world, and they totally understand that our world is electromagnetic and that we are electromagnetic, and yet they also then talk out of the other side of their mouth about gravity and all of the pseudoscience that goes along with that. It's so interesting for me to think about the fact, like, oh man, you're so close because you already know the reality. It's just that you've been given these different categories that have been a repackaging of that reality. So I've been just buying some books that I've seen these guys recommend, and I've been trying to do a lot of reading in those areas.
Okay. It gets to that point, doesn't it? Because even, I mean, I want to ask you both about both these things, but have you reached any real solid, have you like a one sentence answer for what the horizon actually is?
Oh, wow. If I, go ahead.
No, please. Yeah, go on, carry on. No, I'd like to hear what you've kind of concluded, because I've seen, you know, you are always looking at it. You're always kind of, I mean, you know.
I don't think that I've gotten specific about that question that you're talking about, but my the simplest answer is the one that's basic enough, and that is it is the apparent optical meeting of the sky and the earth. Wherever that happens, it could be on the terrestrial plane or it could be on the aquatic plane. It's where the sky apparently meets the earth. Okay, that's it. That's it. Now, if you want to metaphysic it, you know, if you want to break it down farther than that, I think we can do that. And this is what I have said on my channel, and that is this: the alternative explanation for the apparent obstruction of targets over aquatic distance, such as lighthouses, oil platforms, islands, or distant shorelines. That apparent obstruction is alternatively explained by the condition of the medium in every situation, either with or without mirage.
Okay.
Which medium is affectionately known as the ether band.
Yeah. 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 That's the thing. There is simply a limit to where we can see or perceive, and that's all we need, isn't it? On a basic survival level. And yeah, I think you're right. It does break down eventually to that metaphysical thing where you end up looking at it microscopically, and you're still never going to really fully comprehend what's going on, because you are talking about light, reflections, and things like that, which are, the more you look at them, the wilder it is. Sorry, you still there? You sound like you dropped your phone or something.
No, I actually was switching to my headset. How do I sound?
Oh, much better, yes.
Oh, that's much better. Yeah. I just stopped driving, so I switched over to my headset.
Okay. Glad you made it.
Yes. Yeah. Yeah, what you were just saying. Oh, yeah, so here's the thing, right? The whole black swan argument, all of this stuff. Look, if I can ask a person, why can't I see this object? And they answer with the confidence and say, oh, it's absolutely refraction. Like, because I know what this target is, and because I know I've seen that target in another condition, and now I can't even hardly see it, or I can't even see it at all, the only explanation for that is 100% refraction. Well, the opposite, the polar opposite, is the same answer. When you can see it, what's the reason? It's refraction. So when you can see an object and when you cannot see an object, the only cause ever and always will be the condition of the medium.
Right. Absolutely. Yeah. You just remind me of when I was kind of having these first thoughts, and then always I loved kind of comparing the medium of air with the medium of water. What if everything was transferred in water and we were doing all our measurements of things falling in water, but also the observational thing?
Man.
You can't see very far through water, right? Even at the clearest water, there's a limit to your visibility. And so, and then I was thinking about how, light, you could be under a light or in a light or illuminated by light, but that would kind of be a sphere of light. There would be a limit to that, blah, blah, blah. And yeah, you just kind of transfer what we can know and experience from that, just a more dense medium, to the air, and less dense allows you to see a bit further, but there's still a limit. That's maybe a real simple kind of analogy, but that's the kind of stuff that was going through my head early on. But obviously,
So check this out, Nick. I'm sure that you can understand this, and the listeners as well. Excuse me. When I go out and make my observations, very often what I see with my naked eye is a very stable and let's see, I'll just use the word stable, I guess.
Mm-hmm.
It's a very stable image. Like I'll look out over the Chesapeake Bay, I'll find the red roof house and I can see it. It looks great, looks stable, not going anywhere. But as soon as I get my camera and zoom in, I'm getting into the quantum mechanics. And all of a sudden, that house is now, it now looks like it's underwater because of the conditions of the air.
Right.
It looks like it's in a river in the air because the house is just moving and oscillating and vibrating.
Yeah.
But you look at it with your naked eye at 6 miles, you can't see that detail.
Right. Right. Yeah.
You know, and so then it's the same way. Now, if you have a trained eye, such as myself, when I go out there, I know exactly what I'm looking at. Not all the time, but sometimes I can call the shot. I'll say, I'm going to see this, I'm going to see this, and sometimes I'm right.
Right.
But sometimes I can see, like I've done this before. I'm shooting on the shoreline, and someone comes up and says, "Hey, what are you looking at?" And I'll say, "You see that house out there?" No, they'll say, "Yeah." And I'll say, "Tell me what you see, just with your naked eye." And they won't describe the mirage because they don't know what it looks like. They can't see it. And I'll say, "Now look in my camera," and they'll go, "Oh, look, there's a mirage there." You know. So all of these observations. If you look at this, and anybody out there, please help me. I mean, I've been asking for help for the past 5 years, and I haven't seen it for myself. And no globe flake on the other side of the field has ever produced the request that I'm about to reiterate here. And that is, please show me any original documentation from the 1700s or the 1600s where these men did more than just stand on the shoreline and look out across the distance and then write down what they think is happening. Because unless you're out there in the midst of the event taking notes, you don't know what's going on out there.
Absolutely. Absolutely, yeah.
And so the punchline is, if these guys from the 1700s, upon which research they've produced is really what our basis for Mirage is dependent upon, all they did was the same thing I'm doing. They stood on the shoreline and looked out with their eyes and squinted and went, that kind of looks like this. Or that kind of looks like this. And then they just made up a mathematical representation of that, and that's what we believe happens. Nick, I don't know if you've watched a lot of my content or whatnot, but I really do believe that the research that I've put in, the research that Sky Free has put in, the research that Wide Awake and others that have gotten out, Taboo Conspiracy, the research that we have done is well, let's see, the research that we have done is more than capable of dismantling the pseudoscience of refraction and mirage, because every time I read that stuff that's out there in the mainstream, I just think these guys have no clue.
No. They haven't even looked. Yeah. Yeah. No, the guys you mentioned as well, absolutely excellent. I mean, just all that, just filming them, getting out there, and all these different conditions. And that's the thing. This conversion, whatever happens at the horizon, it happens in all weathers. You can't put it down to one thing. And
the other thing that I'll say, now that I'm thinking about what you asked me, the other thing I'll say about the horizon is, if I say it this way, it's the apparent meeting of the sky and the land or the water, and it is the optical phenomenon of refraction. So the way that I've said it on my channel over and over again is, I'll take a kick to both shins with pointy boots for this. The horizon always, always 100%, with or without mirage, the horizon is always the result of refraction.
Okay. Let the shin kicking begin. No. Yeah, I mean, do you want to elaborate or?
Well, the only thing that I can say is if a person doesn't have any experience thinking about this or looking at the horizon, that's fine.
Uh,
Like you said before, just take this into consideration and think about it. You don't have to believe it. Just
Right.
listen to the argument
Yeah.
and then do your own research,
Yeah.
which if you do your own research, you have to include your own empirical zetetic investigation. You
Right.
can't just go out and read the mainstream and then watch my video and then choose which one you want. You've got to, in this instance, because you can do this, do it yourself.
Absolutely.
I think that if you do it yourself, I think, unless you're just hell bent on holding on to your ball belief,
Uh-huh.
I think that you would seriously find things that would help you critically assess the position that you think is true, which would be the globe model, right? So what I would say to a person, how would I substantiate my claim that the horizon is always the result of refraction? If you go out, as I have done, and you find a target and you take a picture at a certain focal length, you've got a certain field of view that fits into your frame, right? So then if you go out 2 or 3 days later and you set your camera up in that same position, you're like, okay, same spot, yep. Same height, yep. Same focal length, yep. Click. And then the image is different. The only explanation is refraction.
Okay. Yeah.
So the target that you're looking at can be apparently closer to you, farther away from you, higher up in the field of view, or lower in the field of view. Guess what that is? That's three-dimensional space, baby. So how does a fixed physical target change its location? The only answer is refraction.
Right.
That's it.
Yeah.
Now imagine, Nick, if we simply went into an elementary, or let's say a middle school, secondary school, and we simply started talking to them about making these observations. I'll pull up a lighthouse. I'll show them the picture of this lighthouse, and I'll say, okay, everybody, look at this lighthouse. Notice everything that's in the picture here. Okay? Everybody, yes? Yes, Mr. Finley. We see. Okay, yes. Then I show them another picture, and I'll say, what's different about this picture? Now, I won't give them necessarily all the information yet. All of the information really is, I have set the camera up in the exact same way I did the first one. So then why is there anything different? Like, why does the lighthouse look different? Why does that tree look different? Why does that shoreline look different? And then make them figure it out.
Right.
And then if you do that, you've given them the seed that will germinate, hopefully, in the future for them to then go and think critically about the globe model.
Yeah.
Because that's all you need.
Yeah, precisely that. It's like, yeah, you can there are conclusions you can reach, but you can't just tell others. They have to go out and look for yourself. And the beauty of all this is that anyone can do that. They can just go and look, and that's all any of us did, right? We got up there, we made the effort to find out for ourselves, and that's real science in a way. That's scientific exploration, and you realize that these ideas again, this indirect evidence that we're given about the horizon. The nonsense that they come up with sometimes in defense.
Well, so
go on.
Yeah, so think about that, right? If you think about presenting the information, like I said, if you take 4 or 5 different images of the same target, and they're all 4 or 5 different, they are all different, but the same target, and you allow the students to cooperate together to come up with an answer, but also to evaluate. So like I'll say, okay, Bobby, what do you think is the reason why the lighthouse looks different? And he says, oh, I think it's XYZ. And then I say, okay, Sally, is Bobby correct? Then she'll say no. And I'll say, why not? And I'll ask, and then I'll force her to evaluate Bobby. And then when Sally's done, I'll say, okay, Stephen, is Sally correct? And he'll say yes. And I'll say, why do you agree with Sally?
Right.
And make them verbalize, right?
Yeah.
Because you're giving them I'm not telling them what I think.
Right.
They don't know what I think.
Huh.
But that's not what science does. Science says, you see the limit to the horizon? That's Earth curve. They don't ask you in class, what do you think that is? And somebody will imagine this, Nick. Imagine we're in the secondary school and we say, okay, here's a picture here. Why does the water stop? And Bobby says, oh, I think that's refraction, sir. And I'll say, okay, anybody else? Sally, do you think it's refraction? No. What do you think it is? I think it's the curve of the earth. Oh, really? Okay. So what's your, why would you say that? And then she explains it. I say, okay, now, Tommy, what do you think of Sally or Bobby? Which one are you going to go with? Where's the evidence? How are we going to solve this mystery, everybody?
Yeah. Get them on it. That's it. Yeah.
Right? But that's not the way science is given to us in school.
No.
We're told this is this, that is that, and the knuckleheads back 500 years used to think the earth was flat.
Yeah. This is it. I mean, it is a case of looking, and yeah, those contradictions in and again, that model, this whole bunch of assumptions just become very apparent. You can't, if you're truly investigating, you can't hold on to those concepts anymore. They clash. They're just repugnant. Because they do not fit with what we actually see, and
well, yeah. Just real quick, I got to wrap up because I gotta finish out what I needed to do the rest of the day. But
okay,
there's another channel that is done by a Globe proponent, and his name is Bobby Shafto.
Okay.
That's the name of his channel, Bobby Shafto. 2 different words. I'll maybe think about it and put it in the chat.
Yeah.
But oh, by the way, did my link work before? I put my link in the YouTube chat.
Oh, I'm not.
And I don't know. I don't know if it. I'm going to put it in again. So anybody out there, can you see this link? This is my. Where'd it go? That's weird. Hold on, I'm going to try again.
I'm watching the chat to see if it pops up. It is on slow mode.
Okay, I just put it in right now.
Okay. Okay, give it a sec. We'll see if it comes up. But otherwise, yeah, it is the plain truth. Yeah, I'm not.
Well, you know what? I'll email you my link, and you can just put it in the description if you want.
Yes, okay. Okay. Happy to do that. Yeah, but excellent, man. I really appreciate it. It's really, really nice to hear your thoughts and just more about what you've what's been on your mind. Yeah.
Yeah. Well, thanks for having the panel, or having this this chat. Oh, what I was going to say about Bobby Shafto is this, because he's making observations on the West Coast. He's in San Diego in California, and he's making these observations, and he's saying, well, what is this, or why do you think this is happening? And the only thing that I've seen him respond to me is I just don't agree with you. Right? So when I say this is this and that is that, he'll say, I understand what you're saying. I just think you're wrong. So Nick, where do I go from there? Where does Bobby go? Where do we, okay, there's just Bobby and me. Bobby says X, I say Y. Where do we go from there? How do we figure it out?
It's challenging, isn't it? Because you know, we need to know about all the elements that affect everything, and that's the thing, we do remain unknowledgeable about a lot. You know, it's like a lot of this, isn't it? We can see the effects, we can, you know, we can label things, but we don't have the means of knowing the real mechanics of any of this. So, you know, you know, personally, just for me, it's just become an acceptance that there is a limit to what we know, but that doesn't stop me exploring and asking questions. But it's like, you know, like you've you know, maybe I'm not sure if I'm giving you a straight answer, but it's you know, again, to me, it's got to that point where you can only kind of start reflecting inwards. And I think for a lot of us, this is a large part of that inner journey, isn't it? You know, we're looking outside for those answers, looking for confirmation of the things that we're told give us the answers to who we are and where we are. And of course, none of them actually make sense. And then you realize that nobody actually knows. And so, yeah, the whole vision thing is bizarre. Reflections do my head in. The fact that you can see the moon reflect, you know, moon and the mountains reflected in a lake, but they're supposed to be really, you know, do you see what I mean? It's like, it doesn't make sense the way reflections actually work, but they're beautiful and they look absolutely fine. So, you know, what are we to break down what we're actually seeing and how it all actually works is still an enigma as far as I'm concerned, you know. But
yeah, I think you're right. I honestly don't know that, even if, like, I think that there's a fifth element in refraction that's not being listed, right? Off the top of my head, what do we have? We have air temperature, water temperature. We've got the alleged gradient of the air temperature. We've got air pressure. We've got wind. You know, like, those are really the four big ones, right? Wind, air temperature, air gradient, and water temperature. When you go to Wikipedia and you want to research on mirages, more often than not, they just talk about the differential between the water temperature and the air temperature.
Right.
And if you go back to some of the more recent videos that Sky Free has put out, they as far as I can remember, in Wikipedia, one of the primary elements of the cause of an inferior mirage is either the air is warmer than the water or the water is warmer than the air. It can go either way.
Right.
Okay?
Yeah.
So, when Sky Free puts out a video with a mirage and the water temperature and the air temperature are the same, what do you do with that? I wasn't expecting a mirage because the air temperature and the water temperature were the same. That's not what a mirage is caused by.
Right.
So, like, what's the answer for this? Is that an anomaly? Is that a mystery? So I happen to think there might be a fifth or sixth element out there.
Okay.
That is not being taken into account.
Dark matter. You found it.
It's called the ether band, my friend. It's called the ether band.
I'm just messing.
Everybody drink. Yeah.
Yeah, the ether band. That's the phrase that you've used, and I like that because it's kind of it's still very much open to exploration. And again, of course, it is subjective, isn't it? That's the thing. Um, so, yeah, yeah. All right, you've got some thumbs up for calling it that, the ether band. Ether band. I don't know if you can see the chat at the moment, but I'm getting some messages. Can you still hear me?
I can, yeah.
Okay, sorry. Yeah, I've got a big error message coming up on my stream thing, but I think it's okay. Yeah. Fascinating. Okay, I dropped your channel link into the chat just now. So,
okay, cool.
I hope that gets people to go and see what you're doing, and keep dropping those red pills with those Uber passengers, man.
Well, like I said, I haven't had an antagonistic conversation yet. I obviously, because I'm the one that's going to instigate it, I'm
Right.
not going to be throwing any punches. I'm just going to be asking questions and trying to encourage people to take a look back and scratch their heads. So that's been going well. That approach, like you said before, if we look at truth as organic and gradual, then we should always be at a sense of openness and peace with everyone.
Yeah.
Because either I can learn from you, or you can learn from me, or both.
Yeah. Yeah.
And why would that ever have to have conflict?
Yeah, exactly. Yeah, because there's this, again, we kind of, by going on this journey, you realize that we've been so influenced and we've been fooled into so many deceptions and self-destruction, and that's needless a lot of the time. It's kind of sad, to see the way things are going. But again, at the same time, like you say, meeting people on a personal level is usually so much more effective than anything else.
Yeah, right. Then a chat or a YouTube stream, you mean?
Well, yeah. I mean, obviously they all kind of help, but there's something about that personal interaction, and I think that's the thing. Us humans will always desire that, and we'll always. That's why solitary confinement is a punishment. It's very healthy a lot of the time, but ultimately we're social creatures, and that's kind of, I watch people, I was thinking about this today, I watch people go about their business here in Thailand, and, a lot of people just have their own thing going on. They might be just selling vegetables or something like that, but their whole day is basically, they spend the day just going around and seeing people and smiling and interacting and just kind of really there's whereas you look at what's happening maybe in the West with, like, when it comes to, just for example off the top of my head, self-automated checkouts, where that human element is being removed from from our daily lives. It's all become very systematic and dry and it's really important. Like you say, you're saying when we first chatted that you're now in a place where you feel more. I would imagine you feel more fulfilled than you were in your previous job. I don't know if the salary or whatever is the same, or the earnings, but at least you're having more human interactions, which is more of a satisfactory, fulfilling existence. Would I be wrong in assuming that?
Yeah, I think that's a good way of putting it, for sure.
Yeah. It just kind of, like you say, we can learn so much from each other, and there's always something that's going to be strange, different, unique about every individual that you meet, right? And yeah, and again, it's they've got to find their own way. Everyone's got to find their own way.
Yeah.
Yeah. Yeah. It's
All right, Nick. Well, if I don't say goodbye, I'll just hang on forever and keep talking and whatever. So thank you so much for thank you so much for letting me hang out. Thanks to everybody in the chat. And yeah. So let's keep up the discussions, keep up the videos and the research.
Yeah. Excellent. No, really, thank you for joining, and it's really, that's really given this whole thing some spice and something for people to think about. I can see that there's a lot of comments in the chat, so that's great. Good to go back through. So thanks, Travis. Again, just a shout out, The Plain Truth. Go and check him out. Subscribe, and keep them coming, my man.
All right, Nick.
Okay.
Take care.
And you, man. Take care. Cheers.
Bye.
All right, bye. All right, nice one. That's really good. Thank you, Travis, for doing that. Let me just go see what's happening in the chat here. I can see that the stream is quite a bit far behind. There's a few people I know have tried asking questions while I was chatting with Travis. But I don't want to get too distracted. Yeah. Okay. Well, Oil Beef, good to see you, man. Lord Racer. NASA, Nautical Aquatic Scuba Academy. Nice one. John 662. The more flat Earth topic is discussed, the less taboo will become. Oh yeah, definitely, John. It seems to be. Even people like Trudeau are talking about it now. It's on a lot more people's radar, and like anything, it just kind of, it's kind of. But at the same time, it's funny, isn't it? Because you still have those hardcore individuals that have set their minds in stone, and they're still approaching this with a very one-sided, bigoted, single-minded attitude. And so hey, if you want to carry on, it'd be great to hear from anyone else that's got anything they want to say about what Travis just said, or anything else to add. Leon, if you're there, you're welcome to come in. I'll stick my email in the chat again. All right, you can email me there, and I'll send you a link. Yeah, good point. I can't read what your handle is there, but the more I know, the less I find out I actually know. Very good point. Yeah. Okay. Let me let me just go back to, because these are kind of like great points for discussion, I think. Let me just check that's showing okay. I think so. All right. So, just kind of looking at the indirect evidence that we're given for the globe assumptions. Eratosthenes establishing a circumference for the equator. This is, again, the whole entire globe is based on that, with a radius and a circumference, but of course that can be on a flat surface or as a globe. I mean, straight off you have something that is one or the other, and it's just been assumed to be the other. Two, other planets in the sky. And this is an assumption that's come from the model. It's nothing, as I was pointing out in my other videos, there was nothing about looking at the planets that would make you assume that the Earth is another one of them. Nothing at all. Yeah. Three, making predictions about luminaries. Again, sunrises, sunsets, all these things, and this is the real stickler for a lot of people, that because they think they can make predictions, then that is a science in itself, because there is a pattern that emerges. But you should try it. Anyone who hasn't, just go out and try it. You can look at the stars or the sun or the moon and you can make predictions about where they will end up or where they will appear and what time. You watch the moon rise and set from. I know it's not easy if you're living in a cloudy place, but it's amazing how you can get familiar. But making those predictions doesn't require any assumptions that you are on another planet. It's just you just see the pattern. But this is, of course, part of the scientific method. Oh, I make a prediction that the sun will set at 6:15 and 27 seconds. And then you go and you record that. Oh, it did set, so my model must be right. And it's just insane. And again, you hear this repetition of, oh, the heliocentric is the best model we've got. And it's not, no. You can refine over time the minute fractions of a second that it might take for the sun to rise or set. And of course, a lot of it will, as Travis said there, depend on conditions, the weather itself. It still isn't exact. And when you look at a lot of these things, it's still a lot of margin of error is given. Oh, it's about right for the recommended average or mean, and la da la da da. There's again, as that article said that we were looking at earlier, there's always wiggle room, and that's often intentional, because if you have a project and you're a scientist that is being sponsored for a project, then you can just keep it going for years and years on end, like looking for the Higgs boson or whatever. I mean, they just make some news, get the funding. For another, we need another 6-year study to do this, and we'll give you the answers to life, the universe, and everything, because of a particle that we've imagineered. And it's just insane. Ships on the horizon. Again, just as Travis has been doing, just keep looking, and you'll see different things happen every single time. They don't disappear down the horizon, and this ridiculous argument that people have about, somehow there's been this misunderstanding or convolution of this idea that you can bring back things that have disappeared beyond the horizon. And all that is just that, no, you can zoom in on things that are on the horizon that you couldn't see with the naked eye, and they will be quite distorted. But you can't just, once something's gone, that's it, it's gone. You can't bring it back with a zoom. And it's just one of those things that is just totally misunderstood and or used as some silly argument. Number 6, I've put Mercury and Venus observed orbiting the Sun. Again, just pointed at as indirect evidence. And of course, you have this idea that everything's supposed to be in circles. So something like observing retrograde motion is not allowed. It's not allowed. Well, that's how we see it. We see these patterns being created over time. But you're not allowed to assume that actual pattern is being created, because the model is supposed to be circles or ellipses. Planets aren't supposed to go back on themselves. Yes, we know there's an explanation, and you can kind of recreate models to illustrate your explanation, but it doesn't mean that's what's actually happening. Doesn't mean you're on the outside of a spinning ball. The ability to navigate, of course, is brought up. This is one of these other pieces of indirect evidence. The Greeks have known for years. Well, you don't know what the Greeks knew. Someone made a really good point the other day so where are all these globes created by the Greeks? Where are they? Where are all these marble globes from Greek times when they knew it was a globe? Go and find some of those to prop up your belief that it's all been known since the Greek times. Yeah, again, that's just a rewriting of history, really, as far as I'm concerned. It's interesting, though, that I suppose the Greeks were known as philosophers, and so maybe their science had reached that point. Maybe this is, when you have a certain level of comfort, then you can spend a lot more time philosophizing, like we're doing right now. Yeah, it's the end of the week, done a lot of work, and it's nice to have a chance to discuss these things with you. And Why not? Will it solve the world's problems? Will it prevent World War III? Well, as Travis was saying earlier on, you plant some seeds, you keep the discussion open, and you encourage thought and investigation and disagreement. We just yeah. Oh, you're working in the garden, Bristolian. Okay. The Greek, I'm reading again from a... Okay. Hang on, we've got Zen Solo. Nick, according to David Ewing Jr., ancient Greece did not exist. Read the books. Very interesting. Okay, yeah. I'm always open to hearing the evidence for, or lack of evidence for. Of course, that's exactly what we're talking about. So, okay, thanks for that. We've got another one saying Greek cosmology is a flat Earth cosmology. The globe was not accepted as mainstream by then, even though that is what we are told. Okay, I think... Hang on, am I getting a... Yes, I'm still here. Okay, sorry. Hangout was asking me if I'm still here. Is anyone else going to send me an email and try and join in? I'd be happy to hear from any one of you that haters that love to call me names in the comments and stuff and tell me how stupid I am. I'm quite happy to hear you out, You're welcome. We've been streaming for a long time now, and any one of you guys can come in and tell me why you believe that we live on a spinning globe. Happy to hear from anyone. So yeah. B. Thomas, oh goody, I'm not too late for our gentle chat about the Greek philosophers. Yes, it can get Tolmulus. Oh, to Tom, hello. One man, hello. Old-fashioned fireplace is symbolic for the flat level earth we live on. Every fireplace has a mantelpiece. I haven't used that word for years. Don't have them in Thailand. The Earth's mantle and the fire below. People standing on the mantle figurines. Okay, yeah. Glenn, okay, some funny stuff there, Glenn. Oh, and Eratosthenes wasn't found in any books until the 80s, apparently. Yeah. This is it, again, all it takes is critical thinking and logic, and this is another thing that a problem we have, this idea that there is a logical conclusion that we live on a globe. Let me just quickly carry on with those pieces of indirect evidence. Again, if you want to come and join, have a chat, nick@stretchoutmedia.com. Send me an email, I'll send you a link to the Hangout. I got number 8 here, explanations for moon orbit. I remember actually when I was a kid going camping, and someone said, oh look, it was daytime, and said, oh look, the moon's in the sky, and you go, oh yeah, cool. And to be honest, when I was a kid, wasn't that fanatical about following the moon, and it's just there, it's in the sky, sometimes it's in the daytime and things like that. And I suppose even until looking into this a bit more about where we are, the nature of where we are, reality, is when you start to really kind of understand the patterns. You never really observed it. This is the thing, it's just, even though you see the moon in the daytime, it's just okay, you might not think too much about it. So there isn't so much of an attachment. There is some fascination, there is some awe and wonder, especially when you hear about space, and then it gets blended in with the whole sci-fi thing. There is again this desire to have some answers, and being given those answers is kind of okay, that's good. So, but I wasn't one to identify with it necessarily. But then, of course, you get a lot of people that do very strongly identify with this search, or feel very much more secure with their answers, and so it's more difficult to break free from that. And I heard an interesting comment today that we all have we can all know that we've had traumatic experiences in our lives, but we each deal with them in different ways, right? So if you've got kind of vindictive narcissistic people, they inevitably have some childhood traumas, and that will often be brought about by selfishness and whatever destructive tendencies, or who knows what kind of home environment. And they then kind of carry that on, carry on the resentment. It's obviously it's always very complex, but then on the other hand, you can be an empath rather than a narcissist. You can be an empath, and you try to understand the suffering, your own suffering, and what have you, your own, but again, it's very difficult to see the big picture until you get out of the kind of situations you're in. Yeah. V. Thomas, we're not obsessed. Bollocks, we're not obsessed with balls. Yeah. So, yes, and of course then, the explanations for a moon. I should carry on with that. The explanations for a moon orbit. So when I first started looking at that, and I'm sure a lot of you did too, it's like, okay, you get this idea, but then you see the moon. Sorry, we're told about the moon's orbit and what it does, and there's all these explanations for how it goes around the Earth, and then you're questioning how the sun's gravity doesn't pull it in, and all these things. You try to get some answers, and you don't really get anything satisfactory. But then you see the moon go overhead every day, and you see the moon possibly disappear behind the sun. And of course that, even then, that might not allow you to explore other ideas, but you can see a different pattern. You can see that actually the moon is probably going overhead every day, as the sun is. Yeah. Excuse me, let me just grab some water. So even when you look and you see that there could be a multitude of different ways of explaining what's going on, we're only told one. Of course, then you've got the moon landings, space exploration, which again, once you start looking into it, you see how they cover things up, or you see the things that aren't shown, and you also see you see how easily people are swayed by their own desire to have answers, or to feel part of a collective mission to spread humanity's seed across the universe. I often wonder whether someone like Elon Musk is just immured, is that the right word, in that fantasy. But then what is it about wanting to get off this rock and explore Mars, if that's really a passion, if that's really the driver behind his enterprises, or whether he's just been handed it on a silver platter, who knows? Doesn't really matter. But there's always that question of how self-aware are these individuals of their own mindset and the roots of what's driving them to do what they do, or be influenced. Yeah. And it always comes down to this human element, doesn't it? It always. Someone call in, so I don't have to talk. Yeah, Alex, you're right. It's it's on the TV every 15, 30 minutes, a spinning globe. Yeah, it's just there. It's in our heads. You know, we just don't even realize. So, satellites and the ISS. Or maybe, you know, I mean, it's okay. I don't deny that people can film something going across the sky, you know, the ISS, but it's insane that anyone could ever actually get up there. I was thinking about this. If you're in, for example, geostationary orbit, I know it's not the ISS is supposed to be spinning so far. Again, we all understand what's supposed to be happening. We all understand the calculated speed that it's got to be going, 17,500 miles an hour or whatever it is, in order to defy gravity and not be pulled down to the earth. This whole thing about the model is understood, but there's very little actual exploration for those that are, you know, should be awe-inspired by the views and the things going on up there. We're just really not being given anything solid or you know, transparent, but it just, yeah, there are so many inconsistencies with real physics, you know, and this is part of it. We've all been through this. I mean, you know, it's and as part of the journey, but it is a difficult one. But this is indirect evidence. Even if you can see something up there, it could be just doing circles in whatever you want to call it, in the ether. I've been looking into gyroscopes, ring laser gyroscopes, and things like that. They automatically, I know I'm jumping around a lot, but they automatically point north. So there is something about this Earth and the energetic field that allows, even you can even put a needle or something on a leaf on some water in the wild, and that needle will end up facing north-south. So what's happening there? There is some kind of magnetic, electromagnetic, whatever, all these other things, some kind of energy, whatever, that has a flow and a direction in, if you like, the ether. And so, you know, that's the main thing that these gyro compasses do, is they align north. So that's what takes the time. And again, this is a video I'm going to do on this. I'm doing some prep for this right now, but it's kind of, you know, you can look at the articles about gyro compasses, and it's got nothing really to do with any assumed movement of the Earth. They are just an inertial reference frame, and they rely on knowing exactly where they were to start with, so that they can then continue to calculate with great accuracy how far they've gone, or what they, you know, which direction, pitch, and whatever they've done. But it has nothing to do with us being on a spinning globe whatsoever. And so, you know, the time is also a thing that obviously is something we've tried to divide into and fractionize into things, but it's really, time is a flow, but it's on that cusp there of being, it's not really tangible, it is abstract, but then you can't deny the existence or the passage of time, even though it is one continuous now. And you can say, oh, there's no past and there's no present. That's not really true. Of course, things happen and they exist until now, but we are only ever living or experiencing the now. Anything going on in our head about the past or the future is really, it's not tangible anymore. It's conceptual. Yeah. and of course it's subjective as well, isn't it? So um, and I suppose all of this is you know, it becomes subjective as well, the whole field of science. And my last point here about the indirect evidence is that you've got so many people doing practical things in the aerospace industry, and communications has come along leaps and bounds. Look at what we're doing right now, but it's not because some signal is going up to a satellite in space. Did I finish my point about geostationary satellites? I was wondering if there was actually I researched it a bit. There's microgravity in geostationary satellites. So, you know, on the one hand, you have to have the ISS going at 17,000 miles an hour to not be pulled down into the Earth's gravitational field, and give the people in there this zero G environment. Yeah. Which is nuts anyway. Yeah, because the zero G thing is only when you're falling. But again, you've got to remember these guys are being constantly, or the machine, that the thing that they're in, the tin can that they're supposed to be in, is being sent violently around this curve at thousands and thousands of miles an hour. So that is constant acceleration. So, you know, they would still be pressed up, because, you know, it's like this conservation of momentum is only ever linear. It's not this anything doing a circle is constant acceleration, because it's constantly changing direction. So even if this ISS was being thrown around the Earth like a tin can, the contents of that tin can would be pressed against the wall anyway, you know, because they, you know, that whole thing about inertia and conservation of motion it only works linear. You can have that argument about linear conservation of the momentum, but the moment something is doing a circle, it's just like being in a car. You know, you're going around a bend at 70 miles an hour, you're going to get thrown against the side. No matter what you do, you're going to be squashed up against there, and so are all your passengers. Yeah, it's just insane that you actually believe that there are people up there whizzing about at 17,000 miles an hour. But you're... Ah, dear. But of course, the fact that you've got thousands of people employed in these industries, building rockets and doing the aerodynamics and stuff like that, you know, it's and they're really smart, and it's that you and just as we were talking about with this thing, it's just tax-funded projects that they just continue to work on. If anyone can find convenience is a killer in that respect. You know, you find an easy thing, easy money, easy source of income, or something that suits you, and you can just keep it. Of course, anyone, you know, a lot of people will just keep it going. As depends on your if you want to carry on being excited about something. But of course, that's the, you know, this indirect evidence that there's people working on all these projects and they're getting an income, and that's just, you know, politicians creating jobs and keeping them, you know, okay, you can have a nice house and a car, work, you know, Space Force One, you know, because they don't care. It doesn't matter if someone's earning, you know, $500,000 a year because they some smart scientists, you know, it doesn't matter. It's just, we know that the money thing is just an illusion anyway. So I wanted to talk about the emotive reasoning. Yeah, it's funny, isn't it, Glenn? Right. The emotive reasoning. So, you know, as I was saying at the beginning, we've got this fascination about our origins. Yeah, of course, we're all fascinated. We all want to know what we're doing here, and all that. There's a strong desire for answers. Of course, when we're kids, it's why, and you know, we're often taught to there's a limit. We're soon taught that there's a limit to the questions we can ask or should ask. Yeah, no, it's all right. Okay. Okay, all right. Okay, guys, I've got to cut this short. I've got some things to take care of. Okay, so I'm going to do is pretty much end it. I'm not sure if I end it on the thing. So, okay, yeah, just some stuff to take care of. Thanks very much for coming along. Thanks to Travis. Thanks to all the rest of you in the chat. Let's catch up later. Sorry about this. Got to cut it short, but things to do. Okay, so have yourselves a good weekend. We'll speak soon. Okay, cheers for now.